Now that we know how to solve linear equations in one variable, let's look at some applications that are modeled by linear equations. To begin, we'll simply look at a direct translation problem. Let's look at this. Twice the difference of a number and 8 is equal to 3 times the sum of the number and 3. Find the number. Of course, we're looking for a number, so we'll let x represent the number, then we directly translate to an equation. So remember, we're told that twice the difference of a number and 8. So twice the difference, twice some difference, and the difference is a number and 8, and its difference, so it's x minus 8, and what's next then is equal to, so we know how to translate that, is equal to, and then it's 3 times the sum, so 3 times sum, and sum means addition, and it's the sum of what? The number and 3. So the number and 3. The sum of the number and 3. I've directly translated. Let's now solve this equation to find our unknown number. How do we solve this equation? Well, let's use the distributive property. So that's 2x minus 2 times 8 is 16 is equal to 3x plus 3 times 3 is 9. No simplifying that can be done on the left side or on the right side. So now we move variable terms to one side and constants to the other side. I will subtract 2x from both sides. So I'll have 2x minus 16. I'll leave a little space. I've just rewritten my equation. Now I'll subtract 2x from the left side and subtract 2x from the right side. The left side, notice 2x minus 2x is 0, so the variable terms have subtracted out, and I have negative 16 is equal to 3x minus 2x, that's 1x, or simply x, plus 9. How do I finish solving this for x? Remember, to solve, we want x by itself on one side of the equation, so I will subtract 9 from both sides. Here's my left side, here's my right side, and I will subtract 9 from both sides. So what is negative 16 minus 9? That is negative 25. And on the right side, the 9's subtract out like I want, and I have simply x. So x represents my unknown number. My unknown number then is negative 25. And I'll let you check, and the best place to check an application is in the statement of the application. But my unknown number is negative 25. Now let's go over some steps we can use for solving applications. Step 1, understand the problem. During this step, become comfortable with the problem, and some ways of doing this are read and reread the problem, choose a variable to represent the unknown, construct a drawing whenever possible, maybe even propose a solution, and check. If you do so, pay careful attention to how you check your proposed solution. This will help when writing an equation to model the problem. Step 2, translate the problem into an equation. Step 3, solve the equation. And step 4, interpret the results. Check the proposed solution in the stated problem and state your conclusion. Keep those in mind, and let's look at the following application. The area of the Sahara Desert is 7 times the area of the Gobi Desert. If the sum of their areas is 4 million square miles, find the area of each desert. Let's go through our steps as we solve this application. Make sure you read and reread the application until you have an understanding of it. And then also, let's let X be what we are looking for. We're looking for the area of the Gobi Desert and the area of the Sahara Desert. So I'm letting X be the area of the Gobi Desert. Then remember, in our application, we are told that the area of the Sahara Desert is 7 times the area of the Gobi Desert. So I can represent the area of the Sahara Desert by 7 times X. That is the area of the Sahara Desert. Now let's move on to step 2, where we translate to an application. We are told that the sum of these areas is 4 million square miles, and we'll use that fact to set up our equation. So how do we translate to an equation? Well, the area of the Gobi Desert plus the area of the Sahara Desert equals 4 million square miles. And that's how we'll set up our equation. Now, step 3, let's solve this equation. How do we solve this equation? Well, on the left side, we have a few like terms that we can combine, and then we will finish solving for X. We'll get X by itself on one side of the equation by doing what? We'll divide both sides of the equation by the coefficient of X, which is 8. Okay, and divide that side by 8. We'll have X then equals, now let's be careful, 8 divides into 40 5 times, and then I have 1, 2, 3, 4, 5 more zeros. So X is 500,000. We've solved the equation. Now let's move on to step 4, which is interpret. Let's interpret this. Well, if X is 500,000, that is the area of the Gobi Desert. Then 7X, which is 7 times 500,000, that's 3,500,000. That is then the area of the Sahara Desert. And these are both in square miles. So we've interpreted, we've written down our answers. Let's see if we can check it. Now remember, we're told that the area of the Sahara Desert is 7 times the area of the Gobi Desert, so that is true. And we're also told that the sum of the areas is 4 million. If you find this sum is 4 million, and of course we're in square miles. So what is our solution? The area of the Gobi Desert is 500,000 square miles. The area of the Sahara Desert is 3,500,000 square miles. Let's now solve another application. 2 angles are supplementary if their sum is 180 degrees. The larger angle measures 8 degrees more than 3 times the measure of a smaller angle. If X represents the measure of the smaller angle and these 2 angles are supplementary, find the measure of each angle. So remember what we are trying to do. We have 2 supplementary angles, so notice my diagram. All I know is one's larger and one's smaller, and I have let X represent the degree measure of the smaller supplementary angle. Now, read and reread the application till you have an understanding. Once you feel you have an understanding, let's not only represent the smaller angle, but let's represent the larger angle. So how can we, in the statement of the problem, represent the larger angle? Remember, we are told that the larger angle measures 8 degrees more than 3 times the measure of the smaller angle. So let's represent that, and I'll write it right here. 8 degrees more than 3 times the measure of the smaller angle. So 3 times the measure of the smaller angle is 3x, and then 8 degrees more, I will add that. So here is how we can represent the degree measure of the larger angle. Now, step 2, how can we translate to an equation? What do we know here that we have not used? We haven't used the fact that these angles are supplementary, which means their sum is 180 degrees, and we can use that to translate to an equation. So in other words, the angle measure of this angle, I'll just use x, plus this angle, I'll use 3x plus 8. What must that sum be in order for them to be supplementary? It must be 180, representing 180 degrees. Now let's solve this equation. This is step 3. How do we solve this equation? Well, we have a few like terms. I don't need to worry about these parentheses because this is addition. So if you'd like, you can take a step and remove the parentheses, but the terms are the same. So let's add a few like terms on the left side. That is 4x plus 8 is equal to 180. How do I solve this equation for x? I will subtract 8 from both sides, and so I'll have 4x plus 8 is equal to 180. I'll subtract 8 from the left side, subtract 8 from the right side. I'll have then 4x is equal to 172. And then how do I solve for x? I divide both sides of this equation by the coefficient of x, which is 4. I'll divide the left side by 4 and the right side by 4. And I'll have what? Let's see, 4 divides into 17 4 times with a remainder of 1, and then 4 divides into 12 3 times. So let's start interpreting what we have now that we've solved this equation. We have that x is 43, which means that is the degree measure of the smaller angle. So let me rewrite this. So we've got some space. We now know that x is 43. How do we find the degree measure of the larger angle? Well, we use this 3x plus 8 then, which equals 3 times x is 43 plus 8, which is, let's see, that's 129 plus 8, which is 137. So the larger angle measures 137 degrees. Now, how can we check this? For one thing, if these two angles are indeed supplementary, their sum must be what? Their sum must be 180. If you find the sum of 137 and 43, that sum is 180, how else should we check? Well, we should make sure that this number is 8 more than 3 times that number, but it is. So we've checked, and we have our solution. The angles measure 43 degrees and 137 degrees. Now let's look at an application that has to do with consecutive integers. Let's look at the following. The measures of the angles of a triangle are 3 consecutive even integers. Find the measure of each angle. Again, make sure you read and reread the application until you have an understanding. I am drawing a diagram. Here I have a triangle, and I'm not worried about the size of the angles in my triangle making it look realistic because I really don't know the answer yet. I'm trying to find the measures of the 3 angles of the triangle. All we're told is that they are 3 consecutive even integers. So let's represent them one at a time. If this first angle measures x degrees, how do we represent the second angle? I'll just call any one of them the second angle. If x is an even integer, how do I represent the next even integer? For example, if x is 12, the next even integer is 14. The next even integer is always 2 units ahead of or in addition to the previous one. So take the previous even integer, add 2 units, you have the next even integer. And how do you get the next even integer? You add 2. So to get the next even integer, I add 2. And that is the next consecutive, I should say, even integer. That's the next consecutive even integer. And I have 3 angles, so what is the next consecutive even integer? That is this plus 2, which is x plus 4. So x plus 4 is the third, or I'll just say third, consecutive even integer. As far as our diagram goes, then, what do we have? Let's say this angle measures x degrees. This angle measures x plus 2 degrees. And this angle then measures x plus 4 degrees. Now that we have completely understood and represented all of our angles, how can we do step 2? How can we translate to an equation? What have we not used yet that will help us translate to an equation? We haven't used the fact that the sum of the measures of the angles of a triangle is what? That sum is 180. So let's use that fact. This angle measure plus this angle measure plus this angle measure should equal 180. Let me give myself a little more room here. So we're now translating to an equation. This angle measure plus, in no particular order, this angle measure plus this angle measure. That sum should be 180. Let's now solve this equation, step 3. To solve, let's look for like terms. What is x plus x plus x? X plus x plus x, that is 3x. And then plus 2 plus 4 is 6. That equals 180. Now we will subtract 6 from both sides. Here's my left side. Here's my right side. I'll subtract 6 from both sides. The left side I'll have simply 3x. The right side I'll have 174. And we finish solving for x by dividing both sides by the coefficient of x, which is 3. So the right side by 3. The left side we have x. The right side, 3 divides into 17 5 times with a remainder of 2, and 3 divides into 24 8 times. So we've solved, now let's interpret. X then is 58, so that's 58 degrees. What is x plus 2? 58 plus 2, which is 60 degrees. And x plus 4, that is either 58 plus 4 or 60 plus 2. It is 62 degrees. All right, so let's check. Are these 3 consecutive even integers? The answer is yes. And is their sum 180 degrees? The answer is yes, so we have checked. At this time, practice solving applications that are modeled by linear equations.